probability. All right, in our next unit for geometry, we are going to talk about probability. The neat thing about this as a unit to me is that I have not taught geometry in a little while, and when I used to teach it, we only did a little bit on probability. And now what we're going to do is a much more in-depth look at it, and you're not really going to see much of this throughout high school. So it's like you're going to learn it here in geometry, and then you don't really do much with it later on. But all depending on what courses you take in college, you may need to study probability again, and it might also be involved in like a statistics sort of study thing. So definitely take notice of the things that we're doing here and try and learn as much as you can from it. All right, so probability, the probability of an event, I'm just gonna read from what we have here now. The probability of an event is the measure of the likelihood that an event will occur. First off, an event is something that's happening. All right. And it can happen or it cannot happen. Like it usually has one or the other. It either happens or it does not happen. And probability is a way of measuring or giving some quantified number to that thing happening. And they describe it here as likelihood, the likelihood that it'll happen. All right, the range of values that we are going to use to describe the probability of an event are going to be from 0 to 1. These are basically decimal forms of percentages. So you may have some experience with probability or phrases of probability, and you talk about them as percentages. These are the same thing here, but these are just being presented as decimal forms. So a 0 probability or 0% probability is something being impossible. It will not happen at all. On the other end, you can have a probability of 1, or you can think of that as 100%, which means that it is absolutely certain that it is going to occur. Then you have a range within those numbers that you can use to describe the likelihood. So right in the middle, a 0.5 or 50% probability means that it is equally likely to happen or not happen. An example of that would be like flipping a coin and it landing on heads. It's either going to land on heads or it's not, and there's not a favorable like side. It's not more likely to be a heads versus a tail. So that would be like a 50-50 or a 0.5 probability. As you go to the left here, closer to 0, the probability decreases towards the number 0. So all depending on the circumstances that we're doing, then you could have a lesser probability. The other direction, you are increasing towards 1, so then it becomes more likely. Example number 1 is not going to get us into an actual probability question yet, but it's going to build up into one. What it is going to talk about is percentages, and to get percentage, I'm going to express a couple values as fractions, which is always the beginning process of doing that. So it says a quality control inspector samples 500 LCD monitors and finds defects in 3 of them. What percentage of the monitors are defective? Okay, so I'm going to start with 3 over 500 because it means that 3 out of those 500 were defective. All right, so if I divide those numbers, I get 0.006. Okay. Now that would be like a raw number from the division. As a percentage, all you need to do is move the decimal 2 spots back. So this is actually going to be 0.6%. So it means that you have less than 1% that are defective, which would make sense because you would need out of 500, you'd have to have 5 of them defective to get to 1 out of 100 or 1%. So we actually have a little bit less than that. Next, we're going to start looking at the 2 big types of probability that we study within this unit. The first is going to be called experimental probability. Experimental probability is the likelihood an event will occur based on the results of an experiment. Notice the relation in the words there. All right, so experimental probability is a calculation that we get which is based on something that has actually happened. It could be a study that we conducted, or in the case of example number 1, it's an experience that we had a certain number of defective monitors. Okay, so experimental probability is going to be based on things that are actually happening. The other type, which we'll talk about in just a bit here, is called theoretical probability, and theoretical is based on what we believe should happen, based off of the things that are available to us, what we would expect to occur from things. All right, example number 2. So referring back to example 1 here, if the company manufactures 15,240 monitors, how many are likely to have defects based on example number 1? Okay, so from example number 1, we found that 3 out of 500 are defective. That gives you a percentage of 0.6. So if we were to manufacture 15,240 monitors, you could multiply that by the percentage that we found to be defective beforehand, which goes back to its decimal form. And that will turn out to be, I'll just take the last answer I got there, multiply by 15,240, and we get 91.44. Which, of course, you should probably just round that off, so we'll call it 91. As far as a company, you could be safe and maybe round upwards, but technically it does round down to 91. Yeah. All right, so this is experimental probability. Something has already happened that gives us a value to work with, and then we can use that value to answer other problems on it. Theoretical probability is most likely the type of probability that you think of when somebody says the word probability. For example, if somebody asks, what is the probability that you're going to flip heads with a coin? Right? You don't actually have to do that to figure out what it is. You just sort of think about what are the possibilities that are available, like heads and tails, and then what's the probability that you'll get maybe heads on this. All right, so it is a ratio, and a ratio is a fraction that we can change to 2% if we want. It's a ratio of comparing the number of favorable outcomes to all possible outcomes. So the favorable outcomes is what we're interested in happening. So maybe when you're flipping a coin, it could be flipping heads, right? And it has two sides, so you have one favorable outcome, which is heads. But you compare that to all possible outcomes. So flipping a coin has heads, it also has tails. So the probability of flipping heads on a coin would be a 1 to 2 ratio, which you could express as a fraction of 1 over 2. Example number 3 is going to look at the probability of rolling 2 dice and the sum of the numbers being 7. All right, so what I did here is I drew this grid, sometimes you call it an array, that can represent all the possible outcomes that are available. Okay, so these numbers on the left are going to represent all the possible outcomes from rolling a single die. Right, you can either roll a 1, a 2, 3, 4, 5, or 6. The top, this is going to represent all the possible outcomes of rolling the other die. You can get 1 through 6. But what we're looking at in this case is a combination of them. Like if you roll a 1 and a 1, you get a sum of 2, right? And if you were to roll a 3 and a 4, that's going to give you a sum of a 7. And this question is asking us to figure out what would be the probability of rolling a 7. So what we do is we figure out all the favorable outcomes. We're going to look at this table here and we're going to identify all the different places where you can add to get a 7. Now, conveniently, if you've never seen this like diagram drawn before, the 7s are all going to be the diagonal that way. You could do 1 plus 6 gives you 7. You could go 2 plus 5 gives you 7. You do 3 plus 4 gives you 7. Like this one, you can do 4 plus 3 gives you 7. Those almost sound the same, but they're two different possible like outcomes because these are different dice, right? You've got one die that you could call it blue. You have another one that's pink, and you could either have a 4 on the blue and a 3 on the pink, or you could have a 4 for the pink and then a 3 for the blue. So two different ways that can actually show up, even though the numbers appear to be the same. All right, everything over here is going to be greater. These are going to be 8s, these will be 9s, 10s, 11, and then it'll be 12. And it just counts down in that direction. So looking at the chart, we have a total of 6 possibilities or 6 ways that you can get a sum of a 7. But the chart tells us all the different ways that things can get added up, right? You could have a 3 and a 1, which would give you a 4. You could have a 1 and a 3, which gives you 4. You can have 1 and 1, gives you 2. You have a total, if you count all the boxes here, 6 by 6, you've got 36 possibilities. So of all the ways that the two dice can roll and be added up together, there's 36 of them, and 6 of those are going to be the sums of 7s. That is your theoretical probability, 6 out of 36. It does reduce to 1 over 6, so you can also describe it this way as having a 1 out of 6 chance that you will roll a sum of 7. As a decimal, I don't think it's going to look that great, but I'll go ahead and type it in. 1 divided by 6 is going to give you about 16 point, that's a repeating 6%. And if you go back to the beginning of the notes, you could also just describe it as a decimal number, which means it can also be written as just 0.1 repeating 6. So all are acceptable, just kind of depends on what you're doing and how you want to present that answer. Example number 4 is going to give us another example of how theoretical probability can look. There's tons of different examples that are out there, but here's a second one that you get to look at. What we have is a jar that contains marbles in it. It has 10 red marbles, it has 8 green marbles, it has 5 blue marbles, and it has 6 white marbles. The question that we were asked is, what is the probability that a randomly selected marble, so this is almost like if you close your eyes, you reach in and you grab a marble, okay? What is the probability that a randomly selected marble is not green? So we could always ask the question, what is it green? We're just looking at the other end of this. Okay, well, if you were asked what the probability of it being green would be, you could say, well, I've got 8 green marbles, and if I just place that number over the total number of marbles, that becomes my probability of drawing a green. In this case, it's just going to be the reverse of it. So what we'll end up doing is adding up all the other colored marbles as a combined favorable outcome to that. Anyhow, where we need to begin for sure is adding up all the marbles. So we have 10, we've got 8, that's going to be 18, plus 5 is 23, plus 6 is going to be 29. So all outcomes, there are 29 different marbles that could be drawn. All right, what we want are the ones that are not green. So we know that there's 8 green. If I just take that away from the 29, that's going to give me 21. You can also get that by adding the 10, the 5, and the 6. And that's it. That's the answer right there. It's about favorable outcomes compared to the overall all possible outcomes. That does not reduce because 29 is a prime number. Not going to reduce, but if you want to divide them, you can see that, there it is, you can see you get 0.72, or what would be 72%. We'll go ahead and add a decimal in there just to do it. Okay, that's another option how you can state that answer.